How's it going, everyone? Welcome to the Lab 1 demo video. So what Lab 1 is about is using a spreadsheet in order to build an automated binary to decimal converter. So in terms of that terminology, hopefully you've had a chance to watch the lecture from earlier on in this week, and you know that binary is just a number system with two digits, 0 and 1, and each of the place values is nothing more than 2 raised to some power. So beginning all the way to the right, that what we call the least significant bit, the digit in that place is worth 1, and each step that we move to the left, we will increase the power of 2. So we have the 1's place, the 2's place, the 4's place, the 8's place, and so on. Remember, every digit in binary is called a bit. If you have a collection of 4 bits, you call it a nibble. And if you have a collection of 8 bits, you call it a byte. And that's terminology that you're probably used to seeing when you read descriptions of computer hardware. Whether it's memory or really any underlying computer hardware, you're probably familiar with not necessarily seeing the word byte, but byte scaled by some kind of metric prefix, like a gigabyte or a terabyte for maybe a external hard drive or so on. So let's actually see how we will get this set up. What I'd encourage you to do is to first navigate to, and I'm assuming most of you have a Google account, but if not, just set one up and then go to Google Sheets. And what we're going to do is actually create a blank sheet here. So if you don't have any familiarity with how spreadsheets work, basically they're organized in what we'll see next week is a matrix type fashion. There's a bunch of columns and there's a bunch of rows. And each one of these individual rectangles within here is called a cell. And I can actually place values in a cell. I really can place any kind of value I want. I could place numbers. I could place text. And I'm sure that you've all worked with this type of spreadsheet software beforehand, so I don't want to say too much, but the key point that I want you to realize is these are cells, and cells are identified by both a column label, which is an alphabetic label, A through K, we can see visibly, and the rows are identified by a numerical label. So why are spreadsheets really, really powerful? Well, in addition to just storing data in spreadsheets and the natural structure that they give you, there's a lot of different built-in functions, some of which we're going to get to explore today, and some of which we'll explore next week. So what I can do, for example, is if I want to show how multiplication works in a spreadsheet, I could take and I could store a value in this particular cell, A1. I could store a value in this particular cell, B1. And then I could take the two values that are stored in those cells, and I can assign the value in a new cell as a function of values in other cells. So for example, if in cell B3, where I'm at right now, if I click on that cell and I hit the equal sign, what that is telling the underlying software is that I want to assign the value in that cell some other value. So I could just make B3 a replicate of B1. And the way that I would do that assignment, once I've hit the equal sign, I can either in the actual function bar up here, type B1 in order to reference that particular cell. Or if I want to use my mouse, I can left click on that cell and notice that the cell name is autofilled. And again, that cell is identified by first and foremost, its column location, which is the letter, and secondly, its row location, which is a number. Once I've completed my assignment, if I hit enter, notice that now the value in B3 matches the value in B1. And of course, if I change the value in B1, the value in B3 will update automatically. So that's not going to be a very useful tool, but what may be useful is if instead of assigning the value of one cell to simply be a copy of another, what if I took and I assigned the value in one cell to be a function of multiple cells? Like for example, if I made the value in B3, the product of the value in B1 and A1, that's a little bit more interesting there. And what I'm able to see there is not only can I assign the value in a cell to be a function of values in other cells, but I can also use some built-in functions within the spreadsheet software, in this case multiplication, in order to do interesting things. Of course, multiplication isn't too interesting. What really makes this interesting is if you notice, if you go to an arbitrary cell and you hit equals, you can see if I start to type something up here, there is going to be a lot of built-in functions that are already built in. And in fact, all of the things that we would want to do today are already built in. You notice when you type B, you see converts between bases. Today, I don't want you to use a built-in function to do the particular task that we're trying to do. I want you to actually code it out or code it. I'm going to use the term code. You usually don't think of a spreadsheet as actually implementing code, but as you'll see when we actually move into software development, a lot of the ideas behind working with spreadsheets are very similar to ideas in software. Notice that here I get this kind of error message that is telling me that I don't know the name of what I tried to type in. And the reason is the underlying software is trying to assign this cell a value equal, and it looks and it just sees this B and it says, hey, I don't know what you mean. Do you mean it tries to autofill? Do you mean a function? Do you mean another particular cell on the sheet, or so on? So key point there is if you see that name error, it just means that your assignment is not complete. So how are we actually going to go about doing the binary to decimal converter? Well, the first thing that we have to do, and there's a little bit of kind of an artistic element to this, and I encourage all of you to work with it and play with it, and you can't break it, right? It's free. So really all that fundamentally you have to do is pick the range of cells where the user is going to actually input the binary number. And if you read what you're trying to do in this lab, you actually want to build an 8-bit binary to decimal converter. So you have to pick a range of 8 cells that are actually going to be your inputs. And you don't have to worry about doing any validation, making sure that someone's typed in a 1 or a 0. We're just going to assume that whoever is using this knows how to actually use the spreadsheet. So what I'm going to actually choose to do is take the first 8 cells in row 1 in order to take in the user input. So what I will do here is I will show you how to do it for a 4-bit converter, and then you can feel free to extend it to the 8-bit case. So the way that I'm going to allow the user to know that I want them to enter their values here is in the row beneath. I'm actually going to enter labels B3 through B0. So one of the things about the binary number system is by convention, you typically will begin your numbering at place 0. So if you notice, if I put some additional text here, maybe I say enter your binary value, and maybe I will move that up to row 1 since that's where they're actually entering the value. Enter your binary value here. So eventually what you're going to do is build this all the way out to an 8-bit number. And remember that if you start at 0, and I thought I did that, sorry about that, the most significant bit will be labeled as B7. So B0 through B7 is actually an 8-bit number. So I'm going to move this descriptive text over by 1 cell. If you're not familiar with keyboard shortcuts, if you're going to work in the engineering field and code a lot, it's a good thing. I'm sure you all know how to cut and paste, but just in case not, or in case it's been a while, that operation that allowed me to do that so quickly was Control X to cut and Control V to paste. So it's going to say enter your binary value here, and I'm just going to put in a particular binary number. And of course, I can't put in the digit 3 because in binary, there are only 2 digits. Now, say I wanted to make this a little bit prettier. Since this is going to be the area where individuals are actually entering their text, maybe I'll select those range of cells and I'll give it some fill color. That way it draws to people's eyes. And maybe the actual labels, I will boldface that text as well. So what people are going to do is they're going to enter their 1s and 0s above, and then I will choose another cell below to actually be the equivalent decimal value or the converted decimal value. It doesn't matter how you actually enter this text. You can make it any cool font that you want. The key point here is just to go through the process of working with spreadsheets, understanding how to assign cells, formulas that involve other cells or functions of other cells, and to actually get how the actual conversion process works. So if I were going to make my converted decimal value live in cell H5, what do I actually need to do here? Well, I'm going to first start by typing the equal key. I'm going to assign this cell the value of, and how am I going to determine it? Well, clearly it's going to be a function of these bits or these 1s and 0s that I have above. Well, in generally speaking, like if you think about it, you might say, well, since there's a 0 here, I don't actually need to include that in my calculation. But you do, because someone could eventually change that to a 1. What we generally want to do is whatever digit is in this least significant bit, we want to take the value in that cell, which you can either type in H1 or you can left click on it, and we want to weight it. We want to assign a place value. So I would use the multiply here to show that I am assigning a place value or weighting 2 to the 0th power. Now you could just write in 1 there, but I think it will be more readable. And as you'll see in a minute, you also could explore some automation approaches here. I'll type 2 to the 0 rather than typing just 1. And then once I've included the value in the 1's place here, I want to include the value in the 2's place. So I'll add on, note that the way I've set up my spreadsheet, the value in the 2's place is in G1. I want to weight that by since it's one bit to the left from the least significant bit, it will be worth 2 to the first, or just 2. Then I will add on the weight of my next most significant bit, which is for me stored in F1. It gets weighted by 2 to the second. And focusing on my formula up here, you see how every stage when I move to the left, the weight is the power of 2 of the weight is increasing by 1. It starts at 0, it goes to 1, it goes to 2, and I'm going to add on the weight of my bit B3, which is just going to be 2 to the third. So this might be a little bit hard to see, but what I'm basically doing is I'm assigning the value where I'm going to store my equivalent decimal value as each of the bits weighted or multiplied by their place value. The bit all the way to the right is weighted or has a place value of 2 to the 0. And as you move to the left, that place value increases by 1 each time. So in this case, for the 4-bit number 1010, that converts to an equivalent decimal number of 10. I could just check it. A really easy way to validate that I'm doing this correctly is if I change all bits to 0, notice that converted decimal value, and maybe I'd want to give it some color as well. I am not an artistic person by any means, but maybe I will just put it in a red. That way it really sticks out. That's more of an orange, but that's okay. And then just see, make sure that it's actually responsive here. Naturally, if I turn the least significant bit to 1, decimal equivalent is 1. Maybe I turn the bit B1 to 1. If you were to do that conversion manually, you would know that since this is worth 2 and this is worth 1, in total, the resulting value is worth 3. And this totally works. And notice if you have 4 bits in this case, the largest value that can be represented is 15, and that is in what is known as unsigned binary. So 4 bits can encode the values from 0 to 15 or 16 total different values, and that corresponds to 2 raised to the 4th power. And that's an important formula to know, that in general, if you have n bits, you can encode 2 to the n different things. If they happen to be representing unsigned decimal numbers, those are the numbers between 0 and 15. However, really what you'll see if any of you are going down the computer engineering road is you could use those binary codes to encode actual different things than just unsigned decimals. But don't let that confuse you. For now, all that you need to do is to set up this binary to decimal converter. And I did it here for the case of 4 bits. So all that you really want to do, if you lay yours out like mine, is to extend this formula to include bits B4, B5, B6, and B7. So you're going to have to add on to that. That's the reason that I thought kind of showing the weights as 2 to a power as opposed to the simplified 1, 2, 4, or 8 is beneficial, because then you can take and you can just copy and paste if you want to save yourself a little bit of time and just update the cell numbers and also update the corresponding weights. So if you have any questions, let me know. Once you got that binary binary to decimal converter implemented, what you want to do, what you're actually turning in, is you're going to tell me here what is the largest 8-bit number that can be represented in binary. The way you'll do that, once you have your binary to decimal converter, how would you make it to the largest number? Well, you're just going to include a bunch of 1s. And notice my value is not updating because I'm not including bits B4 to B7 in my calculation. But once you have updated your spreadsheet, just set all the bits equal to 1 and see what that converted value is. And that's the answer that you're looking for here. And then the second thing you want to do is convert this binary number to decimal. In order to convert 1001, 1011 to decimal, you'll just go in, you'll take all of these values, and you'll set them equal to the number you're trying to convert, which is 1001. I have that correctly. And then 1011. So going back to my sheet here, I need to make 1001, 1011. So mine updated a little bit. That is not the correct answer, but you want to have the bits set in this way, and then just read out that that decimal base value. And then the last thing that I'd like you to do is click on the share button, and you have to give your file a name. So maybe I'll say Henry Lab 1. And then once I've saved it, what I would like you to do is change the access to anyone with the link, and then copy that link and actually paste it in the bottom here. And I will add, before I post, a question here that says place the link to your Google Sheet. And you would just place that here. So how you're going to get full credit for this is to have the link to your Google Sheet, have the actual value that you get when you use your converter to convert this binary number to decimal and tell me the largest 8-bit number that you can represent in binary. So this will be the easiest lab that we have by far. And if you've used spreadsheets before, it'll probably only take you like 5 to 10 minutes, but hopefully it'll be a good exercise to go over the binary to decimal conversion, because you will have to do that both on your first homework and your first test. So reach out if you have any questions. If not, I'll talk to you all soon.